Okay, today we're going to talk about alkanes and alkenes. First, what is an alkane? Are hydrocarbons which contains only single bonds that are called alkanes. This isn't a single bond, a carbon, a bond, and a carbon. They are called saturated hydrocarbons because there is a hydrogen in every part or in every possible location. Like for example in this, we have a carbon, and as we know, the carbon can only have 4 bonds, and here we have the 4 single bonds. The general formula of alkanes is CnH2n plus 2. In my right side, I have a table that we're going to use later, which have the number of carbon of a parent chain and our root word. If we have 1 carbon, we will put meth, and so on. We will continue to show you how to, or the nomenclature of alkanes according to the UPAC system. Okay. Our first example, we have this structure. There, I'm going to draw it. We have carbon, bond, carbon, bond, carbon, bond. Okay, this is our structure. Our first step is to identify what type of bond are we using. First step, type of bond. The type of bond that we're using in the structure is a single bond, as we can see. Some is single, and when we talk about single bonds, we are talking about alkanes. Perfect. Then, the second step is to identify the longest parent or the parent chain of carbons, or longest chain of carbons. Only of carbons. So, the longest chain of carbons we have in here is this one. We have a carbon, a carbon, a carbon, and a carbon. So this is our parent chain. According to this table, the number of carbons in my parent chain, we will use a root word. So, we have 1, 2, 3, and 4. Before we decide what root word we are going to use, we need to number the carbons. So, it's 1, 2, 3, and 4. Okay. We already numbered them, so we can choose the correct root word for the carbons. So, as we have 4 carbons, our root word that we're going to choose is but. So, as a result, we will have our first part of the word, which is the parent chain or the root word, and a pair of letters that let us know that it's an alkene. How can we know that? Okay. When we have alkanes, we are going to use the last letters, N. So, the result of this structure is the number of carbons in the parent chain and the set of letters that let us know that it's an alkane. So as a result we have butane. Butane is this structure. Okay, let's continue with another example. A complex one. We have okay, this is our structure of an alkene. What is the first step that we need to do? To identify the type of bond that we are using. The type of bond that we are using are, as we can see, in all single bonds. Single bonds. When we are talking about single bonds, we are talking also about an alkane. Perfect. Now that we know that it's an alkane, we need to identify the longest chain of carbons or the parent chain. Okay, how can we know that? In this structure we can have many chains. For example, this can be one, this can be one, this could be another one, or this could be another one. Something that you need to take in account is that the chain needs to be a single line. In any shape, but it needs to be a single line. For example, it can be like this, or like this, or like this, but not like this. This is not a single line, you have two lines. And the chain needs to be in a single line. So, the parent chain that we are using, or that we're going to identify, is the longest one. So, these have 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. Or it can be 1, 2, 3, 4, 5, and 6. So, the longest chain in this structure is this one. Once we identify the longest chain of carbons, we need to number them. Something that you need to take in account are the alkyl groups. These are called alkyl groups. So, we can start number them from left to right or from right to left. If we start number them from right to left, like this, 1, 2, 3, 4, 5, and 6. We have one alkyl group in number 2, in carbon number 2, and an alkyl group in carbon number 4. So, 2 plus 4 equals 6. But if we start number them from left to right, we will have 1, 2, 3, 4, 5, and 6. We will have an alkyl group in number 3 and an alkyl group in number 5. This gives 3 plus 5, 8. We need to choose the one that is less. So, 8 is greater than 6, so we will take this one. So, we will start counting from right to left. Okay. Now that we number them, we need to continue with the alkyl groups or the branches. Okay. The alkyl groups have specific numbers, and it's also with a root word of these ones. Now, how can we name it? There is only one alkyl group. So, one alkyl group equals to meth. So it's methyl. The termination "-il" means that it's an alkyl group. Let us know there is an alkyl group. And meth that is only one. Okay, we continue. So, meth, let us know that is 1, and il, that is an alkyl group. We have also 1 in here. So, we will name it the same as this one, methyl. Okay? Once we name them, and also the parent chain, as a result, we will have first, in the result you first put the alkyl groups and then the parent chain. So, we will have, where is located the first alkyl group? In number 2. So you will put 2, comma, the second in number 4. Between number and number, you put a comma. Between number and letter, you put a hyphen or a dash. Okay, so 2, 4. When we have 2 of the same, but in different places, we put the prefix "the." That means 2. Okay? Dimethyl means that we have 2 methyls in the structure, and the numbers give a specific location. So we have 2, 4 dimethyl, and the name of the parent chain. That is, we have 6 carbons. Number of carbons in the parent chain, 6. Hex. So we use dimethyl, hex, N. So we can know that it's an alkane. We use the termination "ane", hexane. So our result is 2, 4 dimethyl hexane. Now a last example, so we can continue with alkynes. Perfect. Okay. Our last example of alkanes will be this one. It's a little bit complex, but easy to resolve or to make. So we have okay, this is our structure. The first thing that we need to identify is the type of bond that we are using. So, the type of bond that we are using, as you can see, are single bonds. So, when we are talking about single bonds, it's an alkane. Okay. The second step is to identify the longest parent chain. As in the example before, we can have many chains in a structure. So, this can be one chain, 1, 2, 3, 4, 5. Another chain can be 1, 2, 3, 4, 5. Another chain can be 1, 2, 3, 4, 5, 6, 7. The longest carbon chain that we have is this one. Remember that it needs to be a single line. So, Once we identify the longest parent chain, we need to number it, taking account the alkyl groups. So, if we start numbering from left to right, we will have 1, 2, 3, 4, 5, 6, and 7. 1 in number 4 and 1 in number 7. 4 plus 7, 11. If we start numbering from right to left, we will have 1, 2, 3, 4, 5, 6, and 7. We will have 1 in number 4 and 1 in number 1. That gives me a 4 plus 1, 5. So we will start numbering from right to left. 1, 2, 3, 4, 5, 6, and 7. Once we number each carbon, we can continue with the alkyl groups. Okay. We need to put a name to each alkyl group. As we only have one carbon equals to meth. And how can we identify that it's an alkyl group? With the prefix, or yes, the prefix of -il, or the two letters, the pair of letters -il. So, as we said, it's 1, we put meth, and to identify that it's an alkyl group, we put -il, Y and L. Meth means 1, -il shows us that it's an alkyl group. And the same in this other alkyl group, methyl. Okay, once that we know it, we can have our result. As a result, we have first the alkyl groups and then the parent chain. So, the alkyl group, where they are located. The first one in number 1, comma. The second one in number 4, hyphen. When we have 2 in different parts of the chain, we use the prefix "the", that means 2, dimethyl. Then, we continue with the parent chain. How many carbons I have in the parent chain? I have 7. So when I have 7, the root word is F. So 1,4 hyphen dimethyl ept, and we need to use or what pair of words or what set of words of letters we put to know that it's an alkane. The second part of the word, that is ane. So is dimethylheptane. And this is our result. I will put you a last example to continue with alkanes. Okay. Okay. We have this structure. Each point that joins the lines that are called bonds, because the lines are the bonds, is a carbon. So, the first thing that we need to identify is the type of bonds we are using. We can see that we have single bonds. So, they are single bonds. When we're talking about single bonds, are alkanes. Okay, The second step is to identify the parent chain. The parent chain that we have in this is this one. Okay? Once we identify, we need to number each carbon. We have the carbon number 1. As in here we don't have branches or alkyl groups, we can start numbering from left to right or from right to left. It's the same. But when we have an alkyl group, we need to check which is more closer to the alkyl group. So, as in here we don't have alkyl groups, we can start numbering from left to right or from right to left. I chose left to right. 1, 2, 3, 4, 5, and 6. We have 6. Now, we have 6 carbons. When we have 6 carbons in the parent chain, we use the root word of X. As we don't have alkyl groups, we have finished. So, as a result, we have the number of carbons represented with the root word as X, and to know that it's an alkane, we use ane. So it's hexane. And this is the result.